Howdy folks, this is Steve, and I want to talk a little bit about some fundamental decisions that you need to make about your trailer and your walls, your exterior walls, and if you can, you should make them fairly early on in the design of your tiny home. Now, you probably don't recognize what we're looking at right here, but I'm going to start. This shaded area here and here, this represents, if we zoom out, the 13 and a half foot width that is the maximum that it's legal in almost all states to tow without requiring an expensive permit. You go any wider than that and you've got to get a trip permit. If you get too wide, you've got to do pilot cars, commercial driver's licenses, a real PETA. So I'm trying to build my tiny home, and 90% of the people, at least, maybe 99, who build a tiny home on wheels, they build it to fit inside this width requirement. So I'm just showing you that the width requirement is something you have to decide almost at the beginning whether you're going to comply with or break. And if you break, it means you're going to need at the very least a trip permit anytime you move it. They're not necessarily expensive. If you, like for instance in California, if you're under 11 feet, a trip permit that gives you a week to move it is only 20 bucks. I think if you're under 10 feet, you don't even need a commercial driver's license. Get beyond 11 feet and you're into pilot cars and much more expensive permits. But this is the 8.5 foot, which means you can drive it anywhere in the lower 48 plus Alaska without needing anything beyond just a regular driver's license. So deciding that you're going to whether or not you're going to build within that is crucially important to the design of the rest of your tiny home. The other part is, what are you going to put it on? And what I'm showing you here, which I'm not going to go over in any great detail, is just the frame of the trailer that I intend to buy. I haven't modeled the trailer in full, but I'm going to show it to you here. Hold on. Where are we? Oh, wrong. Thought I had that. Oh, here we go. Here we go. Okay, so they're called Iron Eagle trailers, and they have done a trailer that I'm really, really impressed with, that is designed specifically for tiny homes. And there's a number of features about it that go into the decision. To me, the most important, oops, I mispositioned my screen. Hold on, I gotta scroll this down a bit. Under the standard features here, you can't, well, they say these perimeter flanges, but this is actually a better picture of it. You can see that as they built it, they've got box beams, but then out here at the end they put in a perimeter flange. And the reason the perimeter flange is important is because you're going to end up putting the bottom plate of your walls right up flush with the edge of that. And the question is, how do you hold that to the trailer? And if there were any kind of beams or anything in here, it would be difficult because you've got to go through a lot of metal, possibly 2 different layers. By putting this little flange on there, it makes it very easy to drill through and bolt down any place you wanted to. Another thing that I'll get to in the future is, oh, do they show it? Oh, they don't show it. Oh, I thought they had oh, here we go. See where they call out here those anchor holes? When I describe the framing, which I'll do briefly, of your subfloor, the question is also, how do you attach it to the trailer? And in this case, they pre-drilled holes for you to do that. For that and a number of other reasons, I'm going to go with these guys' trailers. Okay, so going back to my SketchUp diagram, I don't have exact dimensions on their trailers, and one nice thing they do is they let you order your trailer with the wheels fore and aft at any specified point, which is important for balance in terms of your tongue weight. By not picking that in advance, I'm able to kind of design my tiny home and then do a rough weight and balance measurement and simply tell them where I want the wheels so that my tongue weight is not going to exceed the capacity of my tow vehicle. So what I'm going to be modeling is really what's going to be happening right in here. And I'm going to get down to the meat of this, because the width of your trailer, the outermost edges, is where the outside face of your outside walls are going to be. And the thickness of the walls then determine how much interior space you have. And once you finish modeling the weather shell and get into the design of the actual interior, the space you're going to be living in, the distance, the inside distance between the walls is something, frankly, you want to maximize. And different people have different ways of answering how to do that. And this is by focusing on the exterior wall, I'm going to show you how I intend to do that. So without ado, here is my full exterior wall. Okay? And I'm going to go through each layer, and I'm going to kind of build from the bottom up. So the first thing I'm going to do is I am going to turn off all of the layers so we can start from a blank slate. Okay? And turn them off. On, off. There we go. So now there's nothing in my model. And then the first layer that I'm going to turn back on, because it's my reference point, actually I'm going to do this later for another reason. I'm going to turn on the subflooring, because the subfloor is generally underneath the bottom plate of the wall. So, the next thing you see is the bottom plate of your wall. And what's underneath here in regular house construction is some kind of joist going out to a rim joist and a cripple wall going down to a foundation. Well, we don't use those in building a tiny house on wheels. Our foundation is the trailer. We typically don't build cripple walls, but the subfloor is built either directly on or just a little bit above the trailer, depending on the kind of trailer you get. So we got that. This is representing the subfloor. It obviously goes off a long way off to the right, but I'm just trying to model where the wall meets the subfloor and a little bit so you can see how I'm building my walls with a particular focus on thickness. Okay. Then obviously your walls have studs, and there are my studs. And then I'm not going to talk about insulation yet, so the next layer I'm going to add, and you'll notice that all of this is built flush up to the edge of the subfloor. Now is when I'm going to go down a bit. Again, if this were building on a foundation or on a typical trailer, it would either be on a full length of joists, or for some trailers are built so that you can actually put the joists holding up your subfloor below the level of the trailer deck and hence gain height, which is also important because along with width restrictions for towing, there are height restrictions for towing. So every inch that you can gain in interior height is important. So, but continuing on the outside, well, I am going to show the insulation. Okay, so insulation typically, while you can get great results from with like 2 or 3 inches thick of rigid insulation on the outside here, giving you clear wall cavities. So I'm not going to try and model this, but so the next thing that might be out from this is insulation. But in a tiny home, because of the width constrictions, you really, really, really want to put your insulation in between the studs. Okay? The next thing out from the insulation is what's called your shear walls. Because, trust me, you need to have, if your walls were nothing but the studs and the top plates, it's called racking. The top of the wall wants to move differently than the bottom of the wall, and hence your walls can actually move the top with respect to the bottom. In earthquake, a light bit of wind, most certainly very easy to do while you're in the tropical storm force winds that occur driving down the freeway on a dead calm day. You start to get winds over, I think it's 15 miles an hour, and your tiny home needs to be able to withstand hurricane force 1 winds, even if there's no hurricanes at all on the planet at the time. So you need to put in sheathing, and this is structural. It is a shear panel as well as being sheathing. Now, and then typically, so that's what you see, and then on the outside of the wall panel, you put in what's called a house wrap. Now this has to do with moisture control in the house. A house wrap such as Tyvek, which I'm convinced is the best product out there and I intend to use, but there are others. It does two things. It keeps liquid water from traveling from the outside in, while it lets water vapor travel from the inside out. So whether you use Tyvek or something else, and frankly there are also some sheathing products that come with a built-in house wrap type layer just as their outside face, and you then get your house rain tight, at least on the walls, just by taping together your shear panels with a special tape. You don't need this extra house wrap step. In any case, this becomes the ultimate barrier against rain coming into your house. And the reason you have water problems in the walls of your house, if you have that, typically isn't because this layer has failed, but because details having to do with penetrating this layer at doors and windows, or at the top or bottom of the wall, or as the wall transitions to the roof, have been done wrong. It's very rare that water gets into your house because of a failure of this rain protective barrier. But there's a problem. This rain protective barrier it's going to break down in sunlight. And if you drive down the road with a house wrapped of Tyvek, that Tyvek is going to just rip itself off. The wind's going to pick it up and carry it away. Same with some people use roofer's felt instead of Tyvek as a rain barrier. That'll work too. So the next thing you need is something to physically protect your rain barrier from sunlight and wind and being hit by somebody throwing a rock at it and putting a hole in it. And that is where your exterior siding comes in. This is what you see on the edge of a house. I don't know what mine's going to be. I've used this particular model because I know that whatever I choose isn't going to be that thick. Now, if you come down here and you look closely, you'll see that I've intentionally not attached that directly to the studs through the rain barrier. That's because as water vapor comes out, especially if it's hotter inside than it is outside, then as soon as it gets through the vapor barrier, it's likely to condense as water. And that is not necessarily good for the either the exterior finish, or depending on how you do it, if you've done that as the rain barrier as part of the structural sheathing, then you can end up getting rain in at the edges there, and again, dry rot. So you need one other thing, and you need some sort of a furring. And this is what I call my rain screen furring. I'm going to show you this one. It's a product I saw in somebody else's. In somebody else's video. I haven't modeled it completely, but the idea here is that you want to create a space in here that will always be a space, and it's not shown on this diagram because this is just a section that's also open at the top, where any water that does either come through from the outside because of a problem with your exterior siding, or vapor that's come from the inside and condensed on there, or water that's come down from the top because you haven't done a good job flashing your roof, it has a place to both trickle down to the bottom, and through the natural convection of cold air wanting to rise and moving air causing evaporation, can ventilate the space in between your rain barrier and your exterior sheathing. And this particular product is a 3/8 inch thick product that is plastic, and it's the one I intend to use because it looks like a really good product to me, etc. and so forth. Rather than put up wood furring, which itself can have problems with the rain. I think this is one good use of plastic in home building. You're trying to make this dry and trying to protect the adjacent materials that are most likely some wooden material from the effects of water. Why would you make that material itself, the one you're using to provide the space, a wood material? Okay, so we're almost there. In fact, we defined the thickness of the wall. The thickness of the wall, well, we haven't quite. On the inside, typically all you end up with on top of this is, you might have a vapor barrier, which is typically so thin as to not be worth modeling for wall thickness. And the placement of a vapor barrier, not a rain barrier, but a vapor barrier, on either the inside or the outside of the wall depends a lot on your climate, and I'm not going to get into that. But you might have a vapor barrier, and then you've got whatever the finish of your inside walls are. And so the overall thickness of your wall is from the inside surface of the interior finish here to the outside of the exterior siding. But realize that this is all in relation to this point right there, which is the outside limits of your trailer deck. Now, as I said, we're talking about mine here. So first of all, you don't want to build your trailer deck to the full 8 foot 6 inches that is the limit, because there are going to be things that you put on your house that increase the width of the house beyond the width of the trailer deck. So it's got to come in somehow, and you need to decide exactly how much it's going to come in, and that's a critical dimension in the design of your house. The other thing that makes my wall, now if this were a regular wall, these would go down a lot farther to cover at the very least the subfloor joists and overlapping the foundation a bit. But in my case, there's smaller pieces going in. There's what I'm calling the spacing plate. It's an atypical, a very unusual bit of construction material that doesn't really apply except in a tiny home on wheels being built on a trailer deck, and I'll show you why in another drawing in a bit about where this comes in. And then here is the trailer deck flange that I showed you over here. Where'd we go? Phooey. That I showed you here, and it's actually almost better seen there. So for the purpose of calculating the wall, I didn't need the rest of the trailer beyond the flange. All I really needed in order to show how my wall was built was show the flange. And what I haven't shown is any connectors. But I'll describe to you what those are going to be. The first thing that's going to go down is the spacing plate. And I'm going to drill a hole through the flange and just put in wood screws. I'm not trying to make a structural connection here. I'm just trying to hold down the spacing plate long enough that I can then build the subfloor on top of it, build the walls on top of that. Once the walls are up, I'm going to be bolting every second or third stud space from here down to there and just making a big, huge sandwich with the bottom plate of the wall on top and the trailer flange on the bottom. Now let me explain the spacing plate, and to do that I've got to go to the other SketchUp drawing here, and whoops, there. And the first thing I want to do is I want to get rid of the bounding box because we're not going to focus on that right now, and I want to show you what my subfloor framing is going to look like. Actually, not yet. One of the features of this trailer is, do you see how the inside of the frame is open? They've sized that vertical distance at 6 inches, so you can put a little half-inch spacer and then a 2x6 joist, which is actually only 5.5, and end up with joists running either way. Because you can put, if you want your joist to run that way, you won't even need rim joists. But those are really, really long joists, ridiculously expensive. If you want to go with more typical joist lengths, then it's better to run your joists this way, and you use those anchor holes I pointed out earlier to put a 2x6 right up against the face running all the way down there as what normal construction would be a rim joist, and then put your floor joists in between your rim joists, and just bring and make that flush with the trailer deck. The problem with that is that if you were to look at this on the end, and I haven't modeled this, but I'll show you. If you were to look at that on the end, I mean, imagine I had a subfloor right on top of this trailer deck. There's another thing that has to do with insulation that's called thermal bridging. And from this point here, going to the inside of my house would only be about 1 inch, and the only thing in there would be metal and 3/4 inches of subfloor. And you can't insulate that. You know, there is no, so I would end up with these long strips around the edge, right at the edges of my floor, that for all intents and purposes aren't insulated. So I elected to do something a little bit different. This is the framing below the subfloor. Now, these joists here out around, these studs here out around the edge are what I'm calling my, my spacing studs. And, I talked about, these were the rim joists that I'm talking about, and my floor studs. And what I did was I made the rim joists, instead of 2x6 to fit the box, I made them 2x8. And then I just used 2x6 floor joists. And what this has done is, I'm just going to hide this so you don't have to look at it for just a second. That means that where I used to have, if this were the bottom plate of the wall, as it would be if I didn't do this, I would have this cold spot with a metal thermal bridge going through it. Now instead, I can take an 1.5 inch thick piece of rigid foam insulation and just fill all through that channel and get much better insulation at the junction of the wall with the floor. So let me put that piece back in that I took out. I just don't want to get rid of it. Unhide. And now normally in houses, because I've done this, I actually was able to save myself 2 joists. Normally you'd have a rim joist on all 4 sides, but because my subfloor is extending all the way out here, let me flash that, subfloor in, subfloor out, subfloor in, the first thing that your floor structure, the joists and the rim joist support, is the subfloor. And it would look like, if that's a rim joist and that's a rim joist, that I'm not supporting my subfloor, but that's where these spacing plates come in. So the distance, normally I've drawn 16 inches on center, which means the subfloor itself has to span 14.5 inches, which is the distance between them. And in a house, many people in a tiny home, many people are tempted to go with 24-inch on center joists, leaving you 23.5 inches unsupported. Well, as you can see, where's my tape measure tool? My tape measure tool, as you can see, the unsupported bit of the subfloor is going to be from here to there, and that's only 11.75 inches. And you may wonder why I didn't start this out at 16 inches on center from one end. They are, but they're 16 on center based on the wall joists. That, let me just throw in one here. No, let me throw in the other. Sorry. I've intentionally made my floor joists. Whoops, I'm off by a little. I've got to fix that, but I'm still close enough. I've intentionally made my floor joists line up with my wall joists because I intend to mark the location of both on this flange in some really, or maybe on this part of the frame, so that I always have an external reference to where both my floor and my wall joists are in case I want to make changes, hang something heavy up on the inside walls, whatever. I'm going to have a permanent reference on the house with me. So, that's why I'm going to stop here. I'm not going to go into the rest of the house design because I wanted to go back here and just explain to you why this particular section shows this extra plate right there. It is spacer plate, so that I can put insulation, though it's not shown in this diagram, but so I can put insulation right in there and not have a thermal bridge from there to there. A couple of other notes about this. I did this particular diagram when I thought I'd put in something normal like a fiberglass insulation or a more environmentally friendly blown-in rock wool or sheep's wool. But I've since decided to build my home airtight, and part of building it airtight, the easiest way to make your walls airtight is to use a blown-in polyiso cyanate. I may not be saying that right, but use a foam in place polyisocyanurate. I think I said that right. Insulation. And the interesting thing about that is that once it's set up, it's rigid enough that it actually adds some shear strength to your wall. So while I've drawn this, my shear panel, I originally thought I would do it with what's called 5/8 inch CDX structural plywood. Yeah, 5/8 inch. Before I make this change, I'm going to check with a structural engineer, but I think I'm going to be able to replace this with a much weaker substance, 3/8 inch oriented stranded board. It's even possible that the structural engineer will say, well, no, if you go with the polyisocyanurate and your house is so small, the loads on it aren't that great, that's enough shear strength right there, in which case this layer here, the sheathing, would reduce to 0. It's 5/8 inch both sides, so that's 1.25 inches. So if he says that, I've ultimately gained 1.25 inches on the inside of the house. Because the other thing is, now, as I said, remember, you don't want to build your trailer to the full width. It's actually 102 inches, because you need to add some stuff on the outside of that to close in your walls. And I also haven't drawn it, but if you can imagine, as water comes off the roof, you don't want it dropping right on the top of all of this. So the roof either has to have a really, really good flashing, in which case you're still going to have rain sheeting down here, or you're going to want some sort of an overhang. So what I did was I said, okay, I got to this point thinking I had good depth walls, that I was going to say that my roof will overhang the edge of the trailer deck by no more than 3 inches. And as I've got the roof right now, am I still in the measuring tape tool? As I've got the roof right now, that's not right. It's not quite. Yeah, maybe it is 1 9/16. But hold on, 0. No, that's not. This is a problem with. I'm at a fairly thin construction now, because we're talking. Well, as shown, this is 5/8 plus 3/8 is 1 inch, plus I think the clapboard total is about 3/4. So that's 1 3/4 inches. So I've got another 1.25 inches to design in a way the roof meets the wall so that rain isn't sheeting down the sides. So overall, I've got, I'm not going to add it all up for you now, but once we talk, this point here to this point on the other side is 74 inches, and that was about the best I could do given the outer bounding box and coming back in. Anyway, so to review, I've shown you a lot of details going off on a few tangents. That's just kind of my nature. But there's two very, very critical decisions that you need to make. One is what is the width of your trailer frame going to be? Whoops. The width of your trailer frame. And number two, how thick what is your wall construction going to be, so you know how much extra room you need outside of your trailer frame in order to fit within the bounding box, and then counting back inside to know what your interior dimensions are going to be. think that's about it. I'm going to review this, and I'm probably going to give you at least a couple of links. I'm going to link to these Iron Eagle trailer guys, and I'm going to link, if I can find it, to the manufacturers of this this rain furring layer that I intend to use. And if I can find it, there was a YouTube video of people building a frame inside an Iron Eagle trailer that I'll link to also if I can find it. So that's it. Hope this has been helpful for you.